Hi, everybody. I believe I'm recording and I'm screen sharing. And this is Sarah. And what we're doing tonight is we are going over using SPSS to describe sample characteristics after you've gathered a sample, regardless of whether it's by random sampling, convenient sampling, or purposive sampling for quantitative analysis. And what I have open that you can see is the teacher grading data demo file, which is on Classroom. Just to make sure that you're familiar with it again, it includes 1, 2, 3, 4, 5, 6 variables that I'll usually call background variables. Those are characteristics of participants. The remaining variables are either just their fairly random ID number or a bunch of scale variables that were the targets of measurement. I'm just going to get rid of that last variable because I created it in a previous attempt at this video. Haven't been having complete luck with this, but I'm working on it. So what we want to do is describe the sample characteristics. We want to describe the sample in terms of their age, gender, highest degree earned, whether or not they're full-time teachers, whether they're certified teachers, and at which, what I call dev or development level, which is not precisely correct, but it's what I named the variable that they are studying to teach. Gender is coded female or male. There's no other. Some people may have preferred not to answer, but we offered no other category for this survey. Higher ed includes high school, associate degree, bachelor's, master's, master's plus 30, PhD or EDD. These are all under values. They're entered by the researcher. Full-time teacher is yes or no. For those people who answered yes to full-time teachers, they were asked if yes, please say whether or not you're a certified teacher, yes or no. And the group at which they were pursuing certification, for whom they were pursuing certification. That includes early childhood, arts, TESOL, and other, which are categories that were dropped from this data set. So everyone in this data set is either pursuing a certification for childhood general education, adolescent general education, or special education at any level. So the first thing is we're going to look at our continuous variable, which is age. You can see that age is a continuous variable. It's a numeric variable that is on a scale level of measurement, which would be interval or higher. And to see what the distribution of a continuous variable looks like, there are a number of methods that you can use in SPSS. SPSS often offers multiple ways to perform the same analysis, especially basic analyses, because there are ways that have accumulated over multiple generations of the development of SPSS, and they tend not to drop an analytic method. They tend to just sometimes make it less prominent, but it still is there in the language. So to get descriptive statistics, you go to analyze and you go to descriptive statistics, and then frequencies, descriptives, explore, and various other things, compare means, probably some of these things. I don't know what turf analysis is, but probably some of the others will give you the basic descriptives. But we're going to look at two now, which would be frequencies and descriptives. Now, you wouldn't really think that you would use frequencies for a continuous variable, because after all, what it will do is tell you something like, well, the frequency of age 20 is one case and the frequency of age 21 is one case. And that's not very interesting. It doesn't summarize your continuous variables. We're going to go back though and see some of the actual options that are under frequencies in SPSS and the advantages. Descriptive statistics, though, is what we'll look at first. And all you have to do to get the descriptives on age is click on the age variable and bring it, just click at that arrow and bring it over to the variables list. One thing you'll notice here is that, excuse me, there is the option to save the standardized variables of whichever variable you're getting descriptives on, which means that for a variable like age, it will standardize those values and create a new variable that's called z-age, which would be the z-score, age as scaled on the z distribution. So the mean age from your sample would be transformed into a z-score of 0. An age that's one standard deviation above the average age would be transformed into a z-score of 1, and so on. That's not useful for our purposes, and it's not checked by default, but occasionally it's a useful option. So you see under options for descriptives, what are your choices? What could you get in terms of descriptive statistics? And one thing you'll see pretty quickly, if you know to look for it, is that you don't get the median. And it's very useful to get the median, which is basically why I never use this command, is that I want the medians. So median is a very simple way of looking at something about the shape of the distribution. And you get these statistics called kurtosis and skewness, which do represent information about the shape of the distribution. But you'll see at some point in your studies, if you continue with quantitative information, that kurtosis and skewness statistics are difficult to interpret. And so these actual numerical values for kurtosis and skewness, I don't particularly find valuable to study. So rather than use the descriptives menu, I'm going to cancel that, and instead I'm going to use some of the options under frequencies. So if you're using frequencies to obtain descriptive statistics on, for instance, age, then you go into the statistics options. And here you'll see that median is a choice. You can get the mean, the median, the standard deviation, the minimum and the maximum, just as you could in descriptives, but with the addition of median. You can also get charts, including a histogram. So you can see the shape of the distribution rather than just getting statistics on it. I don't usually get much out of showing the normal curve on the histogram, so I never choose that option. Before you run frequencies, you want to make sure that the display frequency, if you're running frequencies for the descriptive statistics, make sure display frequency tables is unchecked, or you get a lot of information that isn't very interesting, like the age 23 occurs with an incidence of 4. So we're going to tell this is okay. And then I have to go and share my output screen with you. There it is. So now you can see my output screen. And you'll see that out of a sample of 283 plus 5 people who didn't answer the age question, so that's a sample of 288, the mean age is 26.4, the median age is 24, and the standard deviation is 7, and the minimum is 19, maximum is 62. So what does that tell us? Well, first of all, the median is below the mean. That means that the mean is above the median. That means the mean is getting pulled up by some characteristic of the values, some outlier at the high end. It's pulled towards outlier scores. The other thing that we see is that the minimum and the maximum are within the range of plausible values for people studying to be teachers. 62 is a little high, but it's possible. If you see a value like 9 or 620, that is probably a data entry error or an error in self-report, but it's some kind of an error, and it's cause for examination of the raw data. And again, in statistics too, we talk a lot about what to do with bad values, but neither of those values is completely implausible. So then the next thing we're going to do is go and look at the histogram. And the histogram shows a considerable skew, a right skew or a positive skew, showing that while the bulk of cases are between the age of 20 and 30, there's a slight number of people who extend into their 50s, and one particular outlier who is more than 60, and that would be that 62-year-old. So that is pulling the mean up and skewing the data. We're not going to worry about the skewed data at this point. We're just going to report it. So what we would report is that for our sample of 283 participants reported their age with a mean of 26.4, parentheses, standard deviation equals 70 or 7.19. The distribution of age was positively skewed, and the median age was 26. I usually don't report the median, but for a positively skewed distribution, oh, I'm sorry, the median age was 24, but for a skewed distribution, I probably would. Okay, so that's describing the sample in terms of age. We will come back to comparing age, which we to assess the representativeness of age in a sample to population values, which is where we finished in the last class, but I think we were all tired by then, and you may have missed that. So the next thing we want to do is go back to our data and look at the categorical data so that we can examine the variables that are categorical and the relative number of participants within each category. So we have all these categorical variables: gender, highest level of education, and so on. And really with categorical variables, you want to just know a couple of things. You want to know how many people in the sample answered the question, and how many people belonged to each category. It's very simple. So we definitely use frequencies to obtain that. So we're going to go to Analyze Descriptive Statistics Frequencies. I'm just going to get rid of age. I'm going to reset that whole command because I want everything to go back to the default, which has frequency tables and no statistics. And I'm just going to ask for each of these 1, 2, 3, 4, 5 categorical variables. You can actually hold down on Shift and use the arrow to select multiple variables, or you can hold down on Control and tap each of a selection of variables you want, if that matters to you. So we want all of those over, and all we want is the frequency tables on them. We would not obviously want the mean on gender because it might give us a value. If gender is coded 1 and 2, it might give us a value of 1.75, which is meaningless. So I have to make sure I'm sharing my output file with you. That was what happened with one of my attempts at this, is that I wasn't capturing the output file. So the first thing we see is that there were no people who were missing on highest level of education, and no people who were missing on which developmental level they were going to teach, but there were one person missing on gender, 9 people missing on full-time teaching, and 194 people missing on whether or not they were certified. Now, that is because in the survey, although there was no logic forcing only those who said they were full-time teachers to report whether or not they were certified full-time teachers, they were encouraged. Only full-time teachers were said, if you said yes to a full-time teacher, then are you a certified full-time teacher? It was a paper and pencil survey. I think, actually don't moment. No, it was an online survey, but it was rather badly configured in that respect, as you will see in a minute. But the 94 who answered, are you a certified teacher, should be out of the number who answered, yes, I'm a full-time teacher. So we look at the gender, we see that there are 226 females and 61 males. That's not unusual in teacher education, so we're not really surprised by the disproportionality of gender representation. And you want to report the valid percent, not the overall percent. The valid percent is the number of females out of the number of people who responded. The percent is the number of females out of 288. But if you have very many cases that are missing, then these numbers could be quite different. So what you want to say, if you have a third of the sample missing from a question, then it's misleading to say that 60% of the sample was female, when in fact it might be a much larger, I ought to be able to come up with these numbers, but I'm just blanking, percent of the valid people, that is the people who answered their sex at all. Enough said about that. I think we can see a place where they differ considerably later. But for reporting this, you would report the frequency of female and the valid percent, and then the number missing. And I'll show you that presentation in a minute. Higher ed, everybody answered, so percent and valid percent are the same. Full-time teacher, yes or no. Again, you report valid percent rather than percent. Most of the people in the sample are not full-time teachers. And as to whether or not they're certified, 94 said, answered the question, and of those, 58.5% reported that they were not certified. Now, this is where things are a little bit funny and have to do with, this is what we call an artifact of measurement. It's that the questions were not asked as well as they could be. 94 people responded that if they were full-time teachers, they were certified teachers, but only 92 reported that they were full-time teachers. So really this number and that number should be equal. People were prompted to only ask this question if they'd said yes to that question. But 2 people additionally, at least, answered the certification question. So there's some kind of minor problem with that. I could debug it. I didn't in this data sample, and I don't know whether it's necessary. I don't know the extent to which in this particular data I'm going to want to dig that deep. But it's a little glitch in data collection. This is a case where valid percent and percent are very different. So your overall sample is 288, but you're only looking within people who answered this question at all because they were eligible to answer it because they had claimed they claimed that they were full-time teachers. So you could say that only 19% of the sample was certified, or I'm sorry, only 13.5% of the sample was certified out of 288, but you don't really know that. It could be that there are people who are not full-time teachers who are certified. What's important is that of those teachers who claimed by answering that question that they were full-time teachers, 41.5% were also certified. So that's the valid percent. Again, this is not a great example because it shows some data problems, but that's part of the reason you go into the descriptive statistics, is because they tell you things about the quality of your data that are important to know. And the last one is for the 3 development levels or developmental areas that are studied here, the participants in the data are pretty evenly distributed around these groups. So how would we present that? We'd present it in table. And I think this table is on Google Classroom as a JPEG, but it looks really lousy as a JPEG. So I'm just showing it here. This is a different data set, so it's different variables, but this is 155 people. You have the variable on a row, and then you have each of the categories for that variable in a sub-row. You report the N in the category, and then the valid percent. This is the way I reported it, and then if any cases were missing. So because no cases were missing, these 2 N's should add up to 155. Because these are valid percents, not percents out of 155, they should add up to 100%. If we have missing cases, these will still add up. The percents in parentheses will still add up to 100% because they are using as a denominator 155 minus 2. And so this is just a way of reporting the characteristics of the full sample while indicating how much missingness there is. So and there's another, these were some if with the different N's. So in various ways, when you have changing sample sizes for different variables and you want to report them in a single table, there's some kind of little tricksy things that you need to do with your tables. So one other thing that I've got 2 more things that we might want to do. One is, what if you wanted to examine variables conjointly? So for instance, you wanted to see whether, what, I'm still going to keep calling it developmental area, even though that's not really the right thing to call it, childhood special ed or adolescent, how those developmental areas were represented, grouped by are they teachers or aren't they teachers. So you're doing kind of a conjoint comparison of participant sample characteristics. And the simplest way to do that, and there are multiple ways again, is using under-analyzed descriptives. Note that we're just doing descriptive statistics. We're just trying to capture our participant section. This is all about our participant section, who's in. And the simple, really cleanest way to do this is using the descriptive statistics crosstabs. Descriptive statistics crosstabs, you choose the 2 variables that you want to examine conjointly. So what we want to do is we want to have yes or no, are they a full-time teacher, in 2 rows going horizontally. And we want, and whether you do it horizontally or vertically or partly a matter of preference, but it affects sometimes the interpretability. And we want to then see a column for each of the 3 developmental levels. So it'll be like childhood development, yes or no, are they a teacher? That's one column. Next column, adolescent, are they a full-time teacher? Next column, special ed, regardless of development level, are they a full-time teacher, yes or no? So we want to ask that. There are a variety of statistics we can ask, options we can ask, some of which you're going to cover later in the semester with Professor Ranellucci, and when you do, I'll come back around to this. But one particular extra thing that I want to do here is get clustered bar charts, which will be a visual display of this. So there are other ways to get the visual displays. There's a whole sub menu like these that is called graphs, that has multiple ways of getting clustered bar charts, but they happen to be available under crosstabs. So I'm just going to get the depiction, both with numbers and charts, of full-time teaching by developmental level. And we had 9 people who were missing. That derives from these 9 people who are just plain missing on full-time teachers. They can't come into the analysis. And these is the numerical distribution. My chart didn't show up. I must have unchecked that. So you see that among the childhood educators, general education childhood, most of them weren't teachers. By far the majority weren't teachers. By far the majority of adolescent teachers or adolescent candidates were not teachers. But interestingly, the majority of people going into seeking some kind of special education certification were already teachers. And just knowing Hunter College, which is where this sample was drawn from, there are a lot of advanced certification programs that include some kind of special education certification. When we were coding these, any program that included the term special education was grouped as special education. So there are a lot of people who are getting combined programs who would go into the special education and were probably getting add-on certificates in special education so that they were already teachers. So that's a factor in how these data were coded, but it is interesting that the people who are going into the category special education are disproportionately have teaching experience. So I'm going to go back up and ask for that again, because for some reason I must have unchecked display clustered bar charts. And I'll just get the bar charts, and it conveys exactly the same information, but graphically. So you see that under the full-time teachers, a lot, very highly disproportionate to the number of adolescent and childhood participants who were teachers, special educators are, and the special educators are much less proportionately, in lower proportion, going to be non-teachers. Did I say that right? Yeah, compared to adolescent and early childhood. For this particular purpose, I would not use a chart because the chart doesn't convey a lot of information that the numerical values would not. Color charts you have to pay extra in publications for, but it's just not an information dense chart. But I did want to show you that there are multiple ways to convey this kind of information. So in fact, I probably wouldn't convey it here either. I would probably just describe it by saying, presenting that table, a table of the sort that I showed you before on the PDF file, and then saying that the full-time teachers in the sample were disproportionately obtaining certification that involves special education students or special education. So I'm going to go back to the data file again, and we're going to do one last thing and then stop. And that is the Why isn't that popping up? New share. All right, I don't get this. I think this should be what you're seeing now. All right. Sometimes it's difficult for me to see what you see. Anyway, I hope you're seeing this now. So the last thing, which I covered in the last class, but I wasn't fully satisfied with the way I covered it in the last class, is the question of whether, let's say that you were trying to have a representative sample on some characteristic, and whether or not you used random sampling or convenience sampling, you still might want to know whether or not your sample was representative of some known population quality. So how do you find that out? This is going to be a statistical test, and it's going to test a mean from a sample statistic, the mean, against a population parameter, mu. Now, the one that we're going to test is age against a population age for New York State teachers. But you may remember that the bulk of our sample are not New York State teachers. They are not full-time teachers at all. So before we test this, we're going to select only those people who are teachers. And this is kind of an extra step that you don't have to pay too much attention to, but I'm going to go down to data. I'm going to select cases, and I'm going to say that I only want to select those cases where there's a certain condition satisfied. So you see this if ... what's the condition that has to be satisfied? And I'm going to say that they have to be someone for whom on full-time teaching, their value was 1, which just happens to be the value that means, yes, they're a full-time teacher. So those are the people I want to select. I'm going to filter out the unselected cases. I don't want to delete them. That will change the nature of the data file rather than just filtering it. So once I do that, if I go into data view, you're going to see that a lot of cases have been filtered out, and the only cases that remain active are things where full-time teaching is 1. So now I can run the analysis just on full-time teachers. And the question again that I want to answer is whether or not my full-time teachers are representative in age of the population of New York State full-time teachers by comparing means. Now, from the National Center of Education Statistics, I know the population mean for New York State teachers. It's 42.5. What I don't know is the population standard deviation. So I can't use the z-test. It requires the population mean and population standard deviation. So I have to use the one sample t-test, which I believe you just covered in Randalucci's class. So the one sample t-test is under Analyze, Compare Means. And one sample t-test says, well, what variable do you want to test? I want to test age. And it says, what's the test value? In other words, what's the value under the null hypothesis? So in this case, the null hypothesis is that the age of the mean age of my sample is not different than the population mean age. The population mu for age is 42.5. So that's the value I'm testing against. Okay, the null hypothesis is no difference between my sample mean and the population mean. The sample mean represents mu, and the alternative hypothesis is that the sample age is different from the population. I don't really have a preference for what direction the difference might be. As a matter of fact, what I'd really like to do is fail to reject the null hypothesis and be able to say that there's no statistically significant difference between the age of my group, and, or at least that's what I like to be able to say, the age of my group and the average age of the population of New York teachers. So I'm going to tell this is okay. Notice that in my output, I think I have to share my output with you again. In my output, I'm down to 91 teachers because I'm only including teachers' age, not the non-teachers. And the average age for the teachers is 28.12. We're comparing that with the test value from the National Center of Education Statistics of 42.5 for the average age of teachers in New York State. The t-value is -22. That's comparing our average age minus the population average age. So our average age is lower. So that's why you have a negative sign there, but we're not directional, so we don't care. And the significance level is less than 0.000. And you're never going to say p equals 0, even though we can't see any digits to the right of those zeros. There's always some possibility that when you're dealing with probabilities, there's always some even minuscule probability that the mean can equal mu. So you just would say p is less than 0.05 or p is less than 0.01, depending on what your a priori alpha was. But this is a extremely large, I mean, we don't talk about how significant something is. And it's not even worth it here to do an effect size. What would I report? First of all, I'm not surprised by this. These were people obtaining certification. We don't expect them to be particularly old. So what I would say is basically that the mean age among the teachers was 28 with a standard deviation of 66.23. And I might just stop there, indicating that they were novice teachers. But I'm going on and saying indicating that they were novice teachers when compared to the New York State mean of 42.5 for full-time teachers. I don't even think I would report the one sample t-test. The results here are so kind of just obvious comparing 28 to 42.5. But if you had something that was kind of higher stakes for demonstrating representativeness, what you would say is that the average age for the teachers in the sample, parentheses, mean equals 28, SD equals 6.23, you can report to 2 significant digits if you want to, was less than the population average for New York State teachers, according to the National Center for Education Statistics, which had a mean of 42.5, and the difference was statistically significant. T equals -22.03, DF 90, P less than 0.05. That's really overkill for this. It's like way overkill, but I just wanted to give you the example of it. And I believe that here I end. And I'm sorry for the length of this. Actually, I condensed 2 into 1 in hopes that this video will actually function. And I'm going to stop now and say goodnight. And I hope you get something out of this presentation.